Hi guys, I wanna first run the code, show you the output, and then I'll try to explain what's going on here. Let's run the code first. Perfect. These green arrows shows us where the arbitrage opportunities are. I also printed here. If you follow this sequence, Turkish lira, euro, Canadian dollar, and then Turkish lira again, you will end up with more money. That's what this program suggests. Let's go to PowerPoint and then I'll be explaining the source code in detail. This program takes this currency exchange rate matrix, put it into lists, and then convert it to their logarithms. Basically, we negate these values. And then we build a graph with these new values. Sorry, I don't know where to put myself. So yeah, we convert these exchange rates to their logarithm, and then with the new values we build a graph, and then we apply Bellman-Ford to this graph and look for a negative weight cycle. I have another video explaining what the negative weight cycle is, but you can think of it as a black hole in the graph. If there is a negative weight cycle in a graph, the algorithm looking for a shortest path enters an infinite loop and keeps running forever. To prevent this, Bellman-Ford has a control mechanism. It catches the negative weight cycle and declares that a correct solution cannot be found for this graph. But a genius, I don't know who, realized that this control mechanism can be used to detect arbitrage opportunities by converting this multiplication problem to an addition problem. Again, this conversion thing happens by taking the exchange rates logarithm. So let's go back to source code and see what's going on here. We basically import the libraries. This is our tuple. These are the currencies that we look for arbitrage opportunities. We can add or remove new ones. Let's add Mexican pesos here. Perfect. We have four main functions. This one calls the API of openexchangerate.org and then extract the data into lists. And then this one take these lists and negate them. Basically, it takes the logarithm of these exchange rates. This is just to visualize the graph and draw a green line among the currencies that we found arbitrage opportunities. And this is the main part of this program. This is what Bellman-Ford algorithm is. If you apply Bellman-Ford to a graph, it explores the entire graph n-1 time. N is the number of currencies here. If we have 7 currencies looking for an arbitrage opportunity, the algorithm will run 6 times, and then it will run for one last time and make sure that there is no negative weight cycle in the graph. But if there's a negative weight cycle, that's something good actually here. It means that there's an arbitrage opportunity. It catches the arbitrage opportunity and prints where is the arbitrage opportunity for us. This is the client side. We just call the functions here. By the way, you can access this source code from our website and from my GitHub. Finally, at the last part of this video, I want to just mention what can be done as a next steps in this project. I am planning to build some graphic user interface, build an AWS environment using AWS Lambda, Amplify, and some databases and APIs. If you think such a video can be helpful, please let me know in the comments so that I can make that video for you. As a second alternative, we can apply Bellman-Ford to crypto assets and we might find something meaningful. By the way, I'm sorry, I forgot to mention this. This currency arbitrage opportunity here may not be profitable at all. Actually, it's very likely that it's not profitable. Due to the transaction costs and fees, probably the cost will be more than the profits. I don't know how much profit is there. Maybe Maybe I should print the projected profit as well here. So I can add a simulation function here. I just wanted to mention that in real life, arbitrage is like a $100 bill in a busy street on the ground. You can think of it. It stays there for very, very short time. It happens, it's still happening. So it's worth trying, but we should be very careful while executing the orders and about the transaction fees, basically. So yeah, applying this algorithm to crypto assets or gold, silver, other globally traded assets might be interesting. So yeah, that's it from me, guys. Please let me know how can we improve this or what can be done next. Thank you very much. See you in the next one.